Thank you very much. So it's great to be here. When I learned that I'll be the last presenter today, I didn't expect crowd like this. I was thinking, oh hell, 5 o'clock, who will be here? So I'm really happy that it's so many people in the room with me. So just briefly to introduce myself, I'm Rynes. I'm based in Czech Republic, but I'm covering this region and doing this hunt of threats and malware that is using DNS for last few years. And I as well joined Infoblox basically almost 2 years back. So just really briefly to skip the marketing part, because this is the last marketing slide I have for you. Infoblox is an American company based in Santa Clara, and we are focusing on securing the users by using DNS as an effective method. So let's go through the parts of DNS. How attackers are actually capable of doing some stuff with DNS, where they can use that. Because as all of us know, DNS is basically IP to name resolution, basically just connect those together. So if you want to go to the google.com, well, you don't know the IP address, but you know google.com, right? So this is something that is basically an open database. You can store information in, and you can read information out. So you just simply follow the RFC. So what I'm presenting to you right now, what is on the slide right now, that's a cyber kill chain framework. It was developed back when Lockheed Martin was actually attacked. And this is basically a picture of their experience, what the attacker needs to do in order to be anyhow successful. So what we are looking at is not some small phishing or some kind of spammer or something like that, some niche group. No, we are talking about advanced persistent groups that have decided, I have the target and I want to get in. So right now you are seeing 7 of different steps on the screen, and only with 2 of them you don't see any kind of nodes that DNS would be involved inside that. So basically it's the basic protocol, and with security we should start with the basics, right? So have a look on number 1, reconnaissance. So what is that? That's basically the attacker doing its homework. It's the attacker learning from any available resource what can be used. With DNS, obviously you can do reconnaissance, just simply go to the domain that you want of the victim, the domain that there is some domain, and just ask about records. You will get an IP address, you will get maybe how many name servers, where are the name servers. So with the name servers you will maybe even learn if they have some mail security, if they are doing something with spam, because you will see TXT records like SFP records. So all of that is basically in the reconnaissance part. Attacker is doing the homework to collect any necessary information. Of course, it's not only DNS, but I will focus on DNS to be sure. The second part is weaponization. So the attacker have learned that the company is using this or that and is based in somewhere. So they will basically use all this information to create something that might be delivered in the second phase. It may be link, it may be payload, like exe file, maybe doc file, something can be delivered. And that's the part number 3, the delivery. So as you might already know, or you probably may know, the delivery part, even the icon on the number 3, it's usually in mail. Most attacks, like 90% of attacks, start with an email, because it's most easiest part to get something in. Well, I usually say that 90% of attacks starts with an email. How many emails starts with DNS? Well, all of them. This is like the delivery part. So when you actually think about it, the DNS can be something that there is some kind of resolution process, again, to get domain IP address to basically send the mail. And with this, you can actually get an answer. So the DNS part inside here, I'm not talking about emails, but it can be the resolution, can be actually the way how somebody can get some other information inside the company. So the DNS infiltration might be here as well as the delivery part. After that, we have exploitation. So what's the exploitation? What's this all about? So attacker has successfully delivered something. Now he wants to run it. And when you're thinking about running the malware or some kind of exploit, you basically are thinking with connection to the DNS, oh, servers, right? The DNS server, I will attack the DNS server, and the DNS server will most probably start to run some kind of script or maybe some exploit, something will happen. Well, I would actually say you're right, but as well, every single machine, like a phone with modern operation system, laptop, everything, it does have some DNS code in it. So it's not only servers, it's also every single machine. And that machine can be, can trigger an exploit to misbehave and do some harm. So that was part number 4, the exploitation. So the attacker will run something. Obviously, if it runs in memory, then you will have a PC that will restart. Lady on reception will just simply close the PC to go home. So it will be done, right? So the attackers don't like that. Attackers like to stay. So they will do some kind of scheduled tasks. They will do whatever. So they will try to do this installation. Obviously, no DNS in this because, well, what you can do with that. What you will do is like install it like scheduled task or something that will run with start. So then we are actually getting to the 6th phase. I usually like to say that the phase number 6 is the most noisy part of them all. Most likely you will get some kind of detection in here. But have a look, it's number 6. Quite a lot of things have to happen before the number 6 can happen. No, will be done. So with that, with the command and control, again, what you can do, basically hide the messages. I've seen command and control over email. I've seen command and control over Google Drive. But as well, you can see command and control over DNS. And I will show you later on a few nice examples of that. So with the 6th part, it's basically how to hide the message that will be not seen. And number 7, this is the last part. This is the action of objectives. Because attackers have some kind of objective, they will have something to do, like steal the data, encrypt the data, maybe disturb the services, do whatever they like. That's their part of the attacks, so that's their objective. But I used to also say this is too late, because the attacker can do whatever he wanted to do in the first place at this stage. And as you can see, we can have like, again, DNS resolution process, and you can exfiltrate data using DNS protocol. So why I was telling you all of this in so many words that you might say, hey, I know that, Jan, why you are rambling all about this one? So that's because I would like to show you a few nice examples. So first example that I have prepared for you, it's APT34. It's an Iranian group. You might know it as Hell's Kitchen or Ulrich. And these guys have targeted Jordanian government. So how they done it is via email. Actually, 2 emails. First one here, second one here. And they were pretending to be an IT employees. Basically some kind of phishing tactic. But if you think about it, this is already step number 3. So they have to do the homework to find out who is the great person to send this email, and they had to do the step number 2, and it's actually this Excel sheet that was attached. So you would say, okay, so they send some Excel sheets to some kind of person. What's inside the Excel sheet? In the Excel sheet, it was relying on the person who received that email that he will allow the macros. Not necessarily with every single attack that you might see, but in this particular case, they relied on that. So they relied on the person that will do. But that's not that uncommon in big organizations, that there are macros that are being used. So they relied on macro. Then, because they done their homework and they learned about the victim, and this was government, so most probably open tenders, they learned that there might be some mail security solution. And in this particular case, it was sandbox they know about. So how to avoid sandbox? Well, the first thing that the macro have done is just simply asking, hey, machine to have mouse? Because show me sandbox solution that have mouse connected. Most of those sandbox solutions, there will be virtual machines. That's basically the second bullet. It's sandbox evasion techniques. So they knew that there might be some sandbox. So let's not fight with that. Let's just go around. So another steps that were happening. So every action was basically recorded, on execution step was reported via DNS queries that are like this: the QW, ID of the step, random number, plus some kind of domain name. So we have example in the line below. And this was basically the green light. This was the command and control message for the for the attacker. And maybe first question, what do you do if you want to resolve a domain name? What is the easiest option how to do it without using dig or NSLOOKUP? Ping, exactly. So what the malware done was basically call win32 ping status VMI function that is embedded in an Excel form. The rest of the lines of the Excel sheet was actually not something that the person have expected. It was base 64 encoded backdoor that was stored in the user forms. So every single line, it was looking like a form, but it was not a formula. It was basically this embedded backdoor. What I also like that they stick to the schedule of running every 4 hours for 20 days. So if the victim have not detected for 20 days, they will not detect it at all. So let's talk about the backdoor. The backdoor inside was .NET binary. It's basically this Santana backdoor. And it was executing pre-coded PowerShell and command and control commands in order to execute command or maybe download another part of a malware and do some other harm and damage. So how these command and control messages might look like, you see actually over here with an IP addresses that, for us, it looks like IP addresses. But would you say that those were IP addresses? They were actually not an IP addresses. For example, on the first row, the last octet was ID of the victim. It's a number. Let's think about the attacker. For the attacker, it's not an IP address. It's how much? 32 bits of data? Think about data space. So this is what have been happening. So if there was some kind of problem on DNS level, obviously the delay was much higher, like for example, sleep for 6 to 8 hours to avoid detection. So when you are looking at this attack, you are looking at a really advanced group. They're thinking, okay, we don't want to get detected. So what they do, if there is a problem, do nothing. And it's nothing, there is not an alert, right? So the domain names that they were using, they actually got registered like 2 to 3 months before. Because if you are talking about like niche attackers, they will not likely register the domain, create a good reputation for it. They will register the domain and use it immediately. These guys have the patience. These guys want it not to be detected. So there are techniques like newly observed domains, newly registered domains. You can avoid all of that. But these guys had the patience to do so. So this was the example of the Santana backdoor. Have anybody thought about use of DNS like this? Or is it something that you see for the first time? Silence, okay. So let's move on to another one example. So this one is malware from, you might know, TrickBot. TrickBot and their variants of TrickBot, there is plenty of variants. So this is only one of them, this Anchor DNS. And you might say, hey, Jan, that's not something new. Why are you showing us this slide? And I'm showing this because these guys have decided to target financial sector, and they decided to target the high importance machines inside the victims. So they were actually accessing the Active Directory controllers. And when you have Active Directory, what else do you have? You have DNS server, because it relies on it. And this Anchor DNS was basically a way how to do command and control communication, and they were actually selling this access to other attackers, basically done a business with that. So what is actually is down below, you basically see what was contention of the messages sent by DNS, command and control over DNS. But because on DNS you cannot send slash, because that's not allowed character, you see like Anchor DNS, host name version, some client identification. The last part is what version of Trickbot it does, that is. So you cannot send it over DNS like this. So what they have done, they've just used a XOR function with this key to basically get something that you can send over DNS. And I'm not showing you because of the Trickbot, this Anchor DNS module. I'm actually showing you because of another thing that is nice and use of such a thing, such access. By the way, if you would say, I have Linux and I'm safe, don't worry. They've thought about that as well. So there is a version for Linux also. So all the things that why I'm showing you this is use of such a module, use of such a command and control. This is the Rynes ransomware. How it was spread? Well, guess what? Email with DocuSign or Excel sheets. And they basically loaded the Bazaar loader and Cobalt Strike beacon, and after that, they done the command and control communication with Anchor DNS. So something that was seen, and we knew it from the past, because the Anchor DNS is something that is from, what, 2017? Basically, it's not new. It's nothing new. But you see the use of that later on. So this is an example of command and control communication. And as well on the picture, and sorry for that, it's not nice picture from the rear, I suppose, but every single line that you see on this table, this is basically command and control message that got an IP address back. For us, it's not an IP address. It's a command and control response, 32 bits of data. But the malware, ransomware in this case, will send queries like this to basically get some kind of trigger. So let's also talk about what we can do about that, because I've shown you 2 examples. I have plenty of other examples, but in 40 minutes, that's not something that I can go through. If you would like to see much more of those examples, let us know, because we are doing a little bit more advanced education about use of DNS by attackers. We are going through many other examples of malware using DNS in much more detail. But what we are capable of doing about this problem is basically have a look on every single query. And what we are doing, we are using three different methods. We are doing signature detection, we are doing reputation, and behavior analysis. So to have some kind of reputation-based, you actually have to have threat intelligence. Because without that, you basically might say, okay, this domain is bad, but for what? How it's bad? Is it bad still? You might not know. So what we do is we create our own threat intelligence. We are looking on the traffic of our customers, and as well we are looking at, like our threat researchers are actively looking on the malware and are trying to find different uses and different IOCs that can be shared with the threat intelligence. But as well, when we are talking about DNS, because we are the DNS resolver, so the reputation is best in terms of ease of computing power, because you just compare the list and you will see, hey, I know that, bad domain, bad reputation, block it. And with DNS, if you don't give IP address back, there is no communication that can happen. But I would like to talk about the behavior part, because the behavior might be something that you'll be interested in much more. I've shown you some command and control examples. I hope you've seen, at least on the rack, how these messages might look like. But I would like to describe you a little bit more why this behavior analysis is so cool and so powerful. So what they are actually seeing is a rating algorithm that is going through different detection methods in order to determine if that query that has been sent, if it's okay or if it's malicious. So what they are looking at is an algorithm that will go through every single DNS query and response, both directions, and analyze different techniques and tactics in order to determine is good or bad. So we see entropy, lexical, engram, frequency size. It's much more, but every single detection method is good for something little bit different. So when we are talking, for example, the entropy. Everybody familiar with entropy? Everybody knows what it is? Good, great. So randomness of characters. So entropy is actually quite good and nice method. But its drawback is tendency to be false positive. So if you look at the graph, the green is good, red is bad, and the brown is potential false positive. I see quite a lot of it. So it's not the silver bullet that you might look for, because it's not okay enough to just go with entropy. But it can give you quite a nice detection rate. So it can detect quite a lot. If you have a script that will create and generate some kind of domain name, then the entropy will be high, and then you will be able to see what's that. Some examples of entropy scores that are on the screen right now. So www is an entropy of 0 because no randomness, it's the same character. Other scores are inside. So as you can see, even special characters, it doesn't matter. It's basically a character that's it's repeating or not. But nice detection method. So we do take a score and move on. Another quite nice detection method is engram analysis. We are doing something that is called 2 gram and 3 gram, bgram and 3 gram. So we are looking at the ratio of probability that 2 characters are by each other and can be by each other. So if you have a human-created domain name, usually we are looking for something that does make sense for us humans. If you have a script that is creating this domain name, or if you have something that is creating some kind of name for command and control, well, the script doesn't care. It will do like QW, QZ, QY, but do you know any words that will start or have these characters by each other? Probably not, because we don't use that. So engram is another characterization that we are doing, and we are checking 2 characters all over the query, and also we are checking 3 characters. So that's how we are detecting, okay, this communication looks weird. This communication is maybe generated and it's not healthy. So this is the source of this classification. You can see that AD and ED, these characters are much more probable to have by each other because edit, admin, those words exist. But again, the probability of these other characters, it's much lower. So this is the lion work that Google have done, because they have 2 books from 1800th century till 2019 and done engram analysis over them in multiple languages. So we actually do have information about multiple languages. So this is the source that we are doing over the engram analysis. So these were just examples what the algorithm is doing. So for example, if you would have DGA, that's domain generating algorithm, this is a way how to avoid reputation by attackers, right? If you want to avoid reputation, just create domain that doesn't have any. So this is examples of different generated algorithms. So these are different generated domain names. And the attacker knows the algorithm, how these domain names will be generated, so he will know that tomorrow at 3 o'clock I will have that domain name, so I will register it up front and I will have the communication to the command and control server. Well, we learned, and many other security vendors have learned how to detect things like this, total nonsense.tld. So what the attacker have done, what the attacker had thought of? Hey, let's create another way how to generate the domain names. So they created the so-called dictionary DGA. So what is this? Is that you will take 2, 3, 4 different dictionaries and just place the words together to generate a domain name. So if you have a look on this Supperbox example, it's a smaller family that is using that, tell me what is wrong with facegone.net. Would you say, hey, that domain was generated? Most probably not. Because if you have a look, n-gram analysis is good, entropy is good, lexical analysis would be good, everything will be fine. So how to actually be able to say that worklift.net is generated domain name? So for that, we have actually leveraged the theory of graphs, and we have discovered, or we have basically seen, that the Achilles heel of such a technique is basically the repeating words. The dictionaries are not endless. So with that, we are actually seeing different words being repeated in this short example, just few words that are repeating. Because normally, when you are talking about the normal healthy domain names, they are in here. Equal spread of different characters, different words. But if you are talking about DGA generated, you will find them here. So what you see is tight chunks of words that are repeating again and again and again. So this is actually something that we are capable of doing. I haven't seen anybody else that is as well capable of doing such a thing like this. So this is a way how you can actually detect dictionary DGA. How to create another way of think of attackers of fooling users? Because users will be always the weak linked. There will be always somebody who will misread, misclick, misinterpret. So if the attacker would like to create some kind of domain that will be a lookalike, it's quite plenty of things that the attacker might do. So it can be addition of letter at the end. It can be repeating of the letters in the middle. It can be placing dots somewhere. Immediately for the machine is totally different domain name. So this is something the attackers also think about when they are looking at, hey, let's plan a phishing campaign. Or maybe, hey, let's attack Jordanian government. Let's pretend like. And that's a little bit of game that I would like to play with you, because it's already almost gone, time is already gone, almost. So I would like to play a little bit of game with you. So who can tell me what PayPal is the correct PayPal to click on? Yes. We have people in the booth. They know the answer. Yeah, so I forgot about that. So if you have seen it, and I've told you already, please do not vote, or maybe you can vote anonymously. But you will most likely recognize what is the wrong PayPal, the middle one. But hands up, who will say it is the first PayPal that's correct? 1, 2. Who will say the last PayPal is the correct one? And you will be right. Is it a lucky guess, or you have seen a difference? It's a lucky guess, most probably, because actually the characters are the same. They are just different codes, because you can have alphabets like Cyrillic and Latin. Both character sets have those characters. Just the one that you don't want to use will have a little bit different code behind it. For the machine, it's totally different domain name, meaning totally different destination. So, by the way, browsers in URL field, they should show you this homographic writing. So it's xn dash dash, then the string without the special character, and then you see the code of the character that is the special one. And now level up. What is good Google? The first one, hands up. Second one, and third one. You don't want to vote because you cannot know the answer, right? So let's see. Well, the first one was the correct one. So if you see this, can you blame the user that he clicked on the wrong link? Yes, you can, but imagine yourself in his position. So he was seeing, clicking, and he was on something else. So this is another thing that you can focus with DNS, because for DNS, every single link is this line. So it's different. So key takeaways from my session. So DNS is open distributed database. You can place information in, you can read information out. It doesn't mean that something doesn't exist, doesn't mean that it cannot have a meaning. So the queries that I've shown you most likely haven't ever existed as a records. But for the attacker, it doesn't matter. For the attacker, it's some string dot his domain name is the string is what he's get. So it can contain any information. As well, the DNS is basically another protocol that will get you the data from point A to point B. And when you have resolvers, remember that if you ask your resolver and the resolver will not know the name, know the answer, he will create his own new session with its known source IP to find you the answer on the internet. So they are actually acting like a proxies. So this is everything that I've prepared for you. So if you have questions, now is the time. But otherwise, thank you very much for staying so late. And I hope that you enjoy the conference.
If there are any questions, we have special Roblox hats. Infoblox. My bad.
So, hi, on your right, I guess. Yeah. You talked about basically command and control servers using, thank you, command and control servers using DNS responses as basically extra information. You've got like 32 bits of info there that you can use as more data. Have you seen the same behavior but using IPv6 responses, considering that, you know, you just have a lot more data in there to pass around?
Yeah. So it doesn't matter if it's IPv6 or IPv4. It's the same. The DNS is the same. You have IPv4 network, IPv6 IP address. It's basically 32 versus 128 bits. If you have a name, it's the same name. So it doesn't matter if it's IPv4 or IPv6. No. IPv6 is actually a little bit, maybe a little bit more of a problem because you have hexadecimal encoded embedded in. So yeah, but for the attacker, whatever works. But luckily for us, the IPv6 is not that great use, although it's actually getting more and more being used over Europe. But yeah, it doesn't matter. You have a domain name, IPv4, IPv6, who cares?
So, for instance, in your case, right, in the case of your company, would more IPv6 traffic be a little bit of a red flag, considering that, you know, there's, like, you have an endpoint that's suddenly requesting a little bit more IPv6 data than usual? Would that be, let's say, a smallish red flag, or is it just like, okay, normal traffic, will analyze it as is?
So you can tackle the problem with two different set of eyes. You can have a look on volume of the traffic from the endpoint and try to determine what is normal and what is abnormal. But take a look on different web pages. You will click on a link, the web page will show up, and there will be plenty of ads. Every single ad might be different DNS queries. So can you say that if your bunch of your users will click on the wrong link and with a whole lot of ads, that is abnormal or normal? So the volume of the traffic is not the greatest indicator. Of course, if you have traffic and if you log the traffic and look at the traffic on DNS and you will see a huge amount of MX domain, that is weird. Why is somebody asking all around, or why is many of people are asking domain that doesn't exist? So most likely you might see maybe data exfiltration. Maybe you will see some malware that is trying to contact command and control. The other set of eyes that you will look at it is basically looking at the content. Is it common to have those characters inside the query like that? Is it common to have the frequency of the queries towards this destination like this? So it will, this is why we have created this algorithm, because we noticed that attackers are hiding this communication into the traffic that not many companies are looking at. Hands up who is logging DNS traffic. You see? We are doing that.
Okay. I got a question here. What would you recommend besides using anti-malware on the computer and using some sort of DNS blacklists? And my second question is, what do you think about top-level domains that still don't implement DNSSEC?
So, about the endpoint solutions. We are not something that you will just simply say, yeah, I don't need endpoint. No, you still need endpoint, because you can have malware that will basically not use DNS communication, right? So you cannot say you don't need an endpoint solution. But as well, I haven't come across many endpoint solutions that would be able and capable of detecting data exfiltration or infiltration using DNS. Why? Because they are not focusing at it. Because what's wrong if your PC or an application is asking about some kind of domain name? It might be that the programmer have created a mess and created bad application that is bugging and asking again and again and again because it cannot remember the answer. Or it might be basically malware that is trying to connect command and control. So determine that. And the second question was about DNSSEC, right?
Yeah.
Yes?
Yeah.
So DNSSEC, what is DNSSEC? It's cryptographic validation of true information that you are getting back. Nothing else. So what you get with DNSSEC is that the answer you get is true. That's it. So who is saying that the attacker might not create DNSSEC validation on his authoritative server? So in my eyes, DNSSEC is great if you want to mitigate threats like a man in the middle or redirects or something like that, that somebody will alter the destination IP address that you are getting. But other than that, if everybody will use DNSSEC, then it's good. Otherwise, sorry.
Thank you. Are there any more questions?
Hi, thank you. I had a question. You mentioned that the browser should show by default the XN -- encoded string,
Yep.
but where exactly do you see it? Do you need to press any key or have any tool installed?
Well, it depends on the browsers and version of the browser, but I think it's like default behavior. The threat is that you will maybe get an email, and the email will display you a link, and this link will be displayed like I shown you. Mm. But do you check the links in your emails that you are getting?
Not really.
Yeah.
Okay. Thank you.
No worries.
Okay,
Thank
one
you for
more
the question.
Hey, so far we've talked about analyzing the query requests for any kind of suspicious data coming through, but what about if there was an attack vector where the attacker changes the request, the response of the query? For example, in a scenario where he wants to deliver more malicious paywall to the compromised instance. Do you analyze the responses?
It's hard for me to understand the question. Is basically can we alter the sound because it's like bum, 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 and it's hard time to hearing it.
My question is, do you do analysis on the query responses as well?
Yes. We are checking the queries itself and as well responses, because sometimes you cannot block off, for example, phishing based on DNS name, because the attacker can generate the DNS name on the fly. There are registries that will allow you to do this basically variables. So you are looking at the responses. So if you see that a bunch of IP addresses is still the same, whatever query you have, you can block that.
Yes, thank you.
Okay, one last question,
Me?
I promise.
Me?
Yeah,
Or
go
no?
on. Yeah,
Okay.
go on.
So, could this be evaded by using short URLs? So the detection. So if you use the short URL service
So what
to
is
hide.
Yeah, so what is the short URL? The short URL is just easier for us. In the background, it will definitely do DNS queries, a bunch of them, with a bunch of redirects. So with that, it's a bunch of DNS queries. So for me, it doesn't matter. It's DNS, I'm on DNS level DNS traffic, so I'm on DNS level. So wherever you want to connect, you need an IP address. So if there is some kind of shorter URL, that will be responded to a bigger
Yes,
URL.
so something that would convert specific commands. So I have the short URL with a very short, for example, cryptic non-human string, right? Mm-hmm. And that one could be transformed in something much more understandable by the malware, by the server. And the answer will come back. So you said that DNS resolution will be repeated. So first I have a short URL, I have an answer, but then again.
So basically, for me, the short URL is on what level we are, on the level of browser. So the browser will try to determine what the URL means. So it will get the domain, it will try to resolve the domain, get an IP address, and then, yeah, so it doesn't matter for me. It's on the DNS level, you are getting queries to the domains, and you are providing IP addresses to connect to.
Yeah,
Okay.
And any false positives? Because I noticed there are a lot of cloud services that have this string in front of the...
So the false positive is a good question, because as I shown you, the entropy, it's prone to have false positive rate quite high. So that's why we are doing all this other analysis. I haven't shown you like frequency, size, gene indexes, classification errors, number of labels. All of those are things that we do check with every single query, because we don't want to have those false positive. My experience with, for example, financial sector that are using our algorithms is that they report me back that they have like 5 to 6 false positive per month. And I don't think that 5 to 6 false positive per month is picking out. It's definitely not 100 per second. Yep. Is it okay? Question? Yeah, answer, sorry.
Okay.
Thank you.
Thank you so much, Jan.